Can everyone just stop breaking the law while I'm making videos? Welcome to part 3 of our Kingroon adventures. By the way, I apologize for some of the background noise in the previous video. I didn't realize I had my carbon filter running, so some of the voiceovers have a murrt in the background. My bad. Regardless, in this episode, what we're going to be doing is looking at some of the print quality that comes off of this machine. Then in the next episode, maybe, I don't know, we'll see how we can address whatever issues turn up. Couple types of things depending on what sort of printer you're doing. Now, you probably noticed I don't really do printer reviews. I did the Ender series because one of my patrons on Patreon sent me the printer, and I was like, hey, everybody's on about this thing. Let's see how well it does. And it turned out to be a pretty solid machine, nice mod platform. I just use it on a daily basis. This one, like I said, I bought it on a whim, so hey, why not? So I don't really have a systematic, like 1, 2, 3 type of a thing. But what I like to do, the type of printing that I do mostly, like rapid prototyping and checking for fit and like just getting a physical object in my hands before moving on to a next step that may cost, more money or something like that. And I don't do a lot of like flowing organic, like, vase builds, but glimpses of the future, we will eventually get this quality out of the machine, which is pretty good, just not in this video. But I actually pulled this video down. It was uploaded with the other ones and queued to go up Wednesday. Hopefully this still goes up Wednesday-ish. In the comments, Wobbly Emily asked me something, and that sparked a thing in my brain where Emily had posted a video about different types of filaments when you're evaluating 3D printers, and how a lot of channels, when they do print evaluations, are like, look how nice this thing can print, and they use like a really nice looking filament. But when it comes down to checking for flaws in prints, like if I drop a new extruder on something and I want to see how well it's extruding, or if I want to see if there's some kind of problems with the Z-wobble or something like that, you need a color that's going to accentuate those flaws, not one that's going to hide it, because it's pretty easy to find a filament that's going to look great under a lot of circumstances. So rather than trying to find filament and methods that hide flaws, I've had to find filaments and methods that accentuate flaws. The colors I found that kind of accentuate those problems the most and make it easiest to see the flaws are either like engineering gray or cyan or something near cyan. I also use shiny black and flat white. And I could bore you to death with color theory on why I think this is the case, but I'm trying to keep these videos between 20 and 30 minutes, so I'm going to resist the temptation. For the most part, if we're looking for surface abnormalities, it's going to be a particular color. If we're looking for dimensional abnormalities, it's going to be a much tighter tolerance filament. Okay. So one last thing before we get into it, and I mentioned this in the last video, but this isn't meant to really be a review of a machine to say like yay or nay, and it's going to sound like overly critical in parts. So before anybody posts this up on Reddit and says, Alex says it's a piece of crap, look at this, I just want you to know that I went into this sight unseen, wanted to be able to evaluate it with a clean slate, and then go through the process of, printing, evaluation, troubleshooting, brainstorming, and then modding, and show you the results as we go along. So yeah, it's not like I'm beating it up or I don't like it. It's a perfectly functional little machine the way it is for particular uses. We just have to figure out what those are and then see what we could do about it if we want to make it fancier in a particular area. All right, let's get into the testing. So now it's time to put the extruder hot in cold in combination to the test and see how well it does. Now, this is going to seem silly, but the first thing we're going to test with the extrusion stuff is the spool holder. I know that seems ridiculous, but hey, they included it, so I'm going to freaking test it. And believe it or not, the spool holder can cause you a whole lot of printing problems. Let me show you what I'm talking about. So what they included here were just these little molded plastic bases that have basically skateboard bearings in there. And you sit this on the desk and you sit your spool on top of it, boom, instant spool holder. But the problem is these bearings are real crunchy. Like, these are super crunchy. Now, what I did for this test was I just made a general shape and I set Cura to only slice it for the surface of the model so that it would be hollow, just a single perimeter. And then I used the post-processing plugin that's built in Change at Z, and that allows you to change certain parameters at certain layer heights. So what I did was just basically change the speed multiplier as we went up, and I wanted to see where we started to run into extrusion problems. But as you can see right here, it's a moot point as far as post-processing script because I started the speed too high to begin with. I think I started at 60 millimeters a second and went up from there. Maybe it was 50, I don't remember. But because the spool holder was tugging on the filament, which was then tugging on the feeder gear, it was not doing well enough, and then it caught up later on and eventually started extruding until it happened on the next layer. Repeat, repeat, repeat. Here's an example on the left of the exact same print that I did, just taking the spool, sticking a cardboard tube through it, and sticking that on a wooden dowel that was clamped to my bookshelf. So yeah. Now, a good way to torture your cooling and your retraction, as well as like your feeder gear and the feeder tension and all that, is to do a lattice test. Now, I actually years ago bought Angus's what did he call it? The torture cube. He sold on what did he sell it on? Gumtree or Shapeways or something like that. Yeah, I paid the dude money for that just because I wanted to support his channel, but I have since lost the STL. So I was like, well, I'm a nerd. Let's print a Tesseract. But it was more like, let's print 1/4 of a Tesseract, and then eventually we're just going to snap off. So yeah, completely insufficient cooling. And as you can see, our feeding was pretty inconsistent. That was with our stock cooling solution. So bolting the stupid herp derp solution on there, you can see we did a lot better in terms of cooling, but in terms of extrusion, retraction, that type of thing, consistency between layers, it was still a nightmare. And that basically comes down to the feeder. And the point of that was it's a real aggressive test. I mean, that's not something you may ever have to worry about with standard prints, but there you go. So as I predicted in the initial unboxing video, there was going to be problems with challenging objects, maybe even everyday objects, when it comes to the tension of the pinch wheel and the fact that our feeder is not very sharp. So you're going to get a lot of skippage, especially with a hard filament like PLA. There was a gentleman in the comments of the first Kingroon video that showed his solution was just printing out a little disc that fit underneath the spring and gave you a little bit more tension. And I'll give even more options in the mod videos to come. But as it sits, the system that's on there prints okay-ish across slow to moderate speeds. I know that might not be what you want to hear, but we'll talk about some tweaks that we could do in the future. Right now, we're just kind of evaluating as it sits. Now time to do some dimensional testing. And remember, what we're going for right here is precision, not necessarily accuracy. When you talk about precision and accuracy, a lot of times the way that they'll teach it in, a college class or something like that is to give you a quadrant chart. So you have two axes, you have precision up one side and accuracy down the other. So precision is repeatability, like how close, every time you do something, how close is it to the previous results and all the other results. Accuracy is how close something is to a target. Let's say you're trying to move something along a linear axis from here to here. If every time you move there and back, you get 3 millimeters away from that particular target, then that's very precise. Every single time we're getting 3 millimeters away. We haven't hit the target though, so it's not accurate. But it's repeatable, so it's precise. Now, accuracy, let's say every time you go here, you are 1 millimeter away, but sometimes it's here, sometimes it's on the other side, sometimes it's here, sometimes it's a little bit closer here. That's accurate because you are getting close every time, but it's not repeatable, so it's not precise. Precise plus accurate means every time you try to move from here to here, you are exactly on target and exactly the same distance away. So linear rails, theoretically, they're very precise, as in you get very predictable movements and repeatable movements along the axis. As far as accuracy, that depends on the rest of the kinematics of the machine. So you have to talk about the rail within a system. If your machine is not accurate, it doesn't matter how precise the rail is, you're not going to get good results because we need a combination of accuracy and precision. When you do an evaluation of like a budget machine, you say, okay, what corners can we cut and still get good results? We know we have our precision nailed because of the linear rail. Not that other systems are imprecise, but regardless, the accuracy and the results part of that triangle, that's what we're going to be evaluating. So I made a couple of these little dummy models just to test it out, and then slice them up so that there weren't any slicer tricks that were making them appear better than they actually are, and place them in different places around the print tray, did them on different prints to compare them to each other with a pair of calipers. This is more an extrusion test than anything else, but I printed out these octagons at different speeds and on different parts of the build plate, checked the thicknesses at different heights and whatnot. Not particularly consistent. The walls varied between like 0.33 millimeters and 0.48 millimeters, so yeah. Printing circles at different places on the build plate and at different extrusion speeds is a good way to see if you're extruding properly, your traction's priming is good, and that see if your belts are parallel to each other and you have a nice straight path. Obviously we don't here. These cubes also show obvious bulging on the corners, as well as some layer height abnormalities or extrusion abnormalities, as well as the parallel dimensions. Now we have some over extrusion on the near the corners and some under extrusion in the middle where it's a little bit narrower. And these tests were done with the stock firmware settings as far as maximum speed, acceleration, jerk, all that. So none of that was done in the slicer. It was just left up to the defaults that were hardwired into the printer's EEPROM. Here we have ringing tests. On the left, this was printed at high speed. On the right, it was printed at low speed. You can see how much more ringing there is, but we do have ringing on both of them. I believe the one on the right, the walls were printed at 20 millimeters a second. There's still some ringing on it. That's because we have a very heavy tool head on here. It's a fairly simple extruder design, like basically Mark Series. You're just getting all of your torque from that big heavy motor on there, as opposed to gearing it down to translate some of the top end speed to low end torque. And theoretically, these round pegs should fit into the round holes in the blocks that I printed out. They don't. Now, partially that's because we have extrusion problems. Other part of that is they're not perfectly round, and you could tell that just using your calipers and going around a little bit. The peg is actually better than the hole in the middle of the cylinder or the cube, but neither's particularly dead on, and between the one and the other that I printed in different parts of the place, the dimensions and the degree of centricity, is that what it's called, is off. Those type of errors can be due to several different factors. If your machine is not square to itself, and if your belt path is not straight. Also, if you don't have belt tensioners, which we don't, so we'll see how big a deal that is. But regardless, I wasn't able to print something like this, which is a snap together mold for a maxi watt hot end block, because the dimensions just weren't good enough for it to snap together, unfortunately. But theoretically, a lot of that can be compensated for in the slicer and the firmware settings, as well as in some hardware mods and corrections, so we'll cover that as we go along. So, let's talk about the firmware a little bit. Now, the firmware is somewhat of a black box. Later on in the video, when I get to the tethered USB printing, I'll show you what the firmware thinks it is, but in terms of what it actually is, I'll have to do some research and see what's supposed to be on there. But if it is what it says it is, then that's GPL firmware, and we don't have the source provided, which is something that you have to do under the terms of using GPL firmware. I've ranted and raved about violations of open source before, so I'm not going to do it here, but you know, big atomic wedgie if you're not playing by the rules. The first thing that got me thinking about the firmware was the fact that it didn't seem to respect some of the moves that I put in the slicer. It just seemed to kind of ignore some of the commands, and then others it carried on from one move into another move and just ended up with some bizarre printing behavior at times. Particularly, no matter how slow I set the initial layer, it would just take off like a bat out of hell. Also, my change at Z post-processing scripts, they didn't seem to have an effect on the speed and the acceleration at a certain point in time, leading me to believe that it may be limited artificially by the firmware. Here's an example of something that I spent an entire day testing just to make sure it wasn't the case, so you know. So I use Cura for most of my slicing unless I have a reason not to, and I just created a profile for this machine using their, profile wizard, their manage your printers or whatever, and in that you have this option right here, which is your G-code flavor, and it's set by default to Marlin, but sometimes there are moves that just don't exist in one firmware as opposed to another, or they have completely different behaviors. So my thought was, let me try a couple different flavors of G-code and see if that has any effect. And I thought I would try out an organic model with a bunch of different types of moves and lengths of moves, straight, flat, curved, that sort of thing. So I downloaded this Nefertiti bust from Victor's Thingiverse page and had at it. The first problem I had, though, was that it was taking forever to slice this model. So I suspected there were a bajillion different triangles in the mesh, popped it over into MeshLab to check that out, and sure enough, there were, in fact, 8 bajillion triangles. So I simplified the mesh a little bit. Grab MeshLab if you haven't, mess around with it. It's a little weird, but, extremely, extremely useful. And then from MeshLab, I went over into Mesh Mixer so that I used paintbrush tools to get rid of some of these overhangs so I didn't have to use support. Sorry, Nefertiti, don't mean to mangle your ears, but, duty calls. I give it the best slice that I could in terms of bang for the buck, speed versus quality, use variable layer height to save myself a little bit of time, and the results were actually pretty good. I mean, my support broke away on the first print, giving her a little bit of a Fu Manchu here, but what are you going to do? I tried 3 different flavors of G-code, RepRep G-code, Marlin G-code, and Repetier G-code, Repetier G-code. And they were actually all pretty similar. I mean, there's hardly any difference among them. But subjectively, Marlin and RepRep were the best, and Repetier was subjectively the worst, but just by a little bit. Oh, and consequently, what looks like horrible Z-banding here, this is actually just the adaptive layers and the lighting and filament. That's not actually Z abnormalities. I'll show you real quick so you don't freak out. On the right, we have the adaptive layers, and on the left, we have even layers, so you can see it prints perfectly fine with the even layers. So having concluded that, it's benchy time, ladies and germs. I printed this benchy with settings that I stole from Prusa's Mark III stock profile, so it should be exactly the same slice, exactly the same infill, exactly the same infill direction, all that stuff. We definitely have some Z issues. We'll get to that a little bit later in the video. The cooling is not as terrible as I thought it would be. I mean, this is set diagonally on the plate, so we do have the most advantage possible for this, but there's no drooping on the bow. This was a super slow benchy, though. Let me compare that with the next print I did, which is a 30-minute benchy, so, much more aggressive settings here. It actually finished. I didn't have high expectations, and it wasn't a train wreck. It wasn't pretty by any stretch of the imagination, but you can see right here, extrusion inconsistencies as well as cooling were the big issues. I also tried a 20-minute benchy, and that super did not finish, so yeah. But honestly, like a sub 20-minute benchy, that's a stretch for most printers, and getting it down closer to 15 minutes, that's when it gets pretty darn crazy. We'll see. I'm going to do some mods to this, spoiler alert, a couple videos from now, and we'll see how well we can do. I don't know if we can do a 20-minute benchy. Maybe we can at least get a 30-minute benchy that looks better than this. Knock on wood. Now, in terms of ripple and bulging, I was experiencing much more ripple and much more bulging on the corners than I am used to, but I'm used to S-curve acceleration. I'm used to junction deviation. I'm also used to linear advance. It's obvious that either those are set completely wrong or they just don't exist. I suspect they just don't exist at all. I printed your standard calibration cubes at 200% novelty size so that it show up better on camera. This one was printed at Prusa speeds. I duplicated some of the Prusa stock settings. This one was printed super duper slow. And we can see from that, we obviously don't get Prusa quality at Prusa speeds. I enhanced the contrast on this photo right here, but you can see the heavy ghosting. And then printed out, I call this wise ass slow. This is like 20 millimeters a second. We still get a little bit of ripple. Let's talk about ripple for a second. Oh, this is a wide angle lens and it has a slight fisheye effect when I get too close to it. I'll stay back here so I look like a human. Basically, ripple is showing us the shock impulse and recovery damping characteristics of the machine. And it can come from a couple different places. Among those places are the compliance of the machine itself. Now, we have a name for people like that I can't say on film. Now, when you're talking about the machine itself, if you're talking about a shock response, if you have two mechanisms, let's say your bed and your print head, just to choose objects at random, if those move together, no impulse response there. If they move together, it's fine. It's if it has some kind of movement this way, some kind of movement this way, they're counter to each other, it's going to and then settle. Second is compliance in anything. So if you, for example, have a belt mount or, a pulley, something like that, that is a little bit compliant, you're going to get bending there. or if you just don't have a particularly rigid structure on your machine. But one big area of ringing that's not really talked about is the magnetic compliance of the stepper motors themselves, because they don't lock into position. They're just held at a particular angle by, you know, force vectors from your magnets, in reference to the, you know, the rotor and the stator. So they're going to have a little bit of an elastic behavior as well. That's not something that's necessarily the fault of the machine. You could say it's something that's the fault of, you know, speccing the motors. But ways that you can decrease ripple are either decrease the compliance in the motors, decrease the compliance in any of your mounts that you have, increase the, I don't want to say increase the rigidity of the machine, but increase the, decrease the displacement relative to each other of the two objects that can move, like your bed and your print head. I hope I said that right. Also, using belts with less compliance, belts that don't have teeth that compress as much, you know, better pulleys that conform better to the shape of the surface area of the belts, that type of thing. I'd love to model that behavior and send you a file that you can mess around with, but a certain CAD company took those features out of the free tier of the software, so sorry, I'm not going to do that. We'll talk about what we could do about it a little bit later. And as far as setting up our profiles, the magic numbers for this machine are 0.04 millimeters. That's going to be every layer height should be a multiple of that. If you want to know more about magic numbers, go to Chep's channel, and he has a magic numbers video up somewhere. I think it was a while ago, but yeah. Anyway, this appears to be a 1.8 degree motor for the Z-axis, which means since we're moving 8 millimeters to 4-start screw, then 0.04 millimeters, that's going to be our magic number multiplier. Magic numbers, they don't always seem to make a difference, but on this printer, it really seems to, at least on mine. So I'm going to print out 2 of these 200% calibration cubes, one using layers that are going to fall on full steps, and the other that just falls on some weirdo random number. And it's pretty easy to see here which one was the magic numbers and which one wasn't. I won't spoil it for you. And since we're talking about aberrant behavior, let's talk about the supposed print resume feature. Now, it does exist, however, I can't get it to work. I tried 4 or 5 times just cutting the power off like this, and you can see, boom, there we go. Well, here's the problem. When the print resumes, it is just air printing. Now, at first I thought this was a jam, but the filament flows freely out of the nozzle. Turns out what's happening, I'll show you here with this little piece of tape. After you resume, the extruder just stops working. Like, it moves, but it just twitches back and forth. It isn't actually pushing any plastic. It also isn't the type of print resume that rehomes the Z-axis and then raises up to the level where you're printing and resumes. It homes the X and the Y axes, but for the Z, it just kind of stays where it is and then tries to go back to the position where it was. And that's fine, except for the fact that when we cut off power to the printer, we are also cutting off, obviously, power to the motors, which means they have 0 holding torque. So the Z-axis is going to settle down to the first magnetic stop in the rotation of the lead screw. Now, you have 50 of these on this particular motor, as opposed to the 200 full steps that you have for, you know, the electrical steps. Let me show you an example. Here is the little clip of the video where I cut off the power, and I'm going to loop this on and off. I put a little flag on the lead screw. So you see how it turns slightly when I turn off the power? That's because it's settling down to that next step in the stepper. So you're going to have a smoosh layer there, or it's just going to knock the build right off the plate. So figuring we have our 8 millimeters of travel and we have 50 of those steps, that means our layer lines have to be multiples of 0.16 millimeters if you don't want that to happen. So 0.16, 0.32, 0.48, 0.64, etc., etc. So 0.16 you can definitely hit with a standard hot end. 0.32 you could probably hit. That's like my fast draft height, as long as you have decent throughput. For volcano nozzle, the 0.48 and the 0.64, those are much more feasible. So I would recommend using those heights if you're using this type of print resume and, like, you know, a 24-hour print that you really don't want to worry about a power outage and then, you know, messing it up because of the gantry drooped a little. And then just a few miscellaneous things here. One thing that really annoyed me was this thumb screw. Now, this is the Z stop. It's nice that there's a thumb screw and it's adjustable, but it's very wiggly. So, you know, if you move that a little bit and it changes the angle, it'll screw up your first layer. That's super annoying. The second thing is I had a heck of a time getting it to connect via USB. I tried all the different options, turning it on, then plug it in, then turning it on, doing it with and without an SD card, etc., etc. And mostly I just got the, echo unknown command quotation marks, which usually just indicates a communication problem of some sort. I even ditched Pronterface and tried to connect directly from the bash terminal, but, well, it did connect, but I got the exact same communication problem, so it was worth a try. What I really wanted to do was send it an M503 and an M115 so I could see A, what firmware it thinks it's running, and B, what settings are stored in the EEPROM for the defaults. But after many tries and reboots, I did finally get it to connect properly, and it took an M115. And it thinks it's running Marlin. Alright. And then as far as getting it to take an M503, these are the defaults that it had stored. So the steps per unit, 92, 160, 160, 800. That says to me that we're probably running in 32 stepping. The X and the Y speeds were limited to 200 millimeters a second, and the acceleration was limited to 1000. There was also no trinamic data, and it wouldn't respond to any trinamic commands, so that tells me that the steppers on the board are running in standalone mode, not smart mode. That's a shame, but it's not the end of the world. And lest you forget, going all the way back to the beginning of the video, I did definitely drop this little SD card in here a couple times. There's an annoying gap between the slot and the chassis. So one last thing, every once in a while when the stars align just right, I would get this kind of a pattern, and it kind of looks like Z-banding, but it's not. This looks to me either like rounding errors or bunching up over extrusion due to like bang bang heating on the bed when you thermal cycle the bed and it kind of flexes on you like a bimetallic strip. Now, I did eventually dig up the configuration file that wasn't on my printer, and it does look like they are using bang bang bed heating, so yeah, that's a distinct possibility. So let's sum up some of the main points so far. First thing I noticed, loud. Those fans are super duper loud. And there's a loud fan in the power supply as well. It's not as loud as the hot end fans, but if you replace those with quieter fans, then you're definitely going to notice a fan in the power supply. Now, we also had print inconsistencies as well as, aberrations, printing errors. Those were due to a bunch of different factors. The feeder gear, the whole cold end, maybe the temperature on the hot end, maybe the belts, the bang bang on the bed could contribute. The slight Z-axis offset, that could be an issue without the ball bearing mod. The USB was flaky. It worked, question mark, quotation marks. But it was definitely flaky. I definitely wouldn't print over USB. That can probably be fixed with a firmware patch, but firmware, question mark, exclamation mark, question mark. I'm gonna have to go and see if Kingroon has provided any updated firmware that deals with these problems. I can't even tell what the version is on mine, and it just self-reports as Marlin version 1, so I have no idea. And I think their only support is through a Facebook group, which I am opposed to on a fundamental level. But regardless, moving on, that SD card hole, super annoying. I know you could print up a plug and stick it in there, that's fine. The power supply, mostly referring to the two main wires that go into your board. Remember from the last video, those were tinned, and with power cycling, that can work its way loose and short itself out. Vibration translating into prints has to do with a couple different issues. If we put fans on there that are a little bit more chill, that might help the problem. Some vibration damping, maybe preload on the linear rail cart, but I won't be able to check that until I get the bearings in. The inconsistent Z end stop is really annoying. I mean, I'm probably just going to have to print a thing and stick it in there. And then we had other problems with the bed other than just the bang bang, in that it's not completely flat, it's bowed up at the top, and it deforms with heat. So that's why you get the varying layer lines when it's hot versus when it's cold. Not a conclusive list by any means, but I just wanted to give you a rundown because you probably forgot some of this stuff by now. Alright then, where does that leave us? Well, fear not. If you're having any of these problems similar to what I'm having, and if you're having problems that I'm not having, or if you are not having the problems that I'm having, let me know in the comments. Because, like I said, this may have been a refurb unit or a return unit or a tester unit or something like that, because there was obvious, like the 3D printed filament guide, there was a groove worn in there, so obviously there was some printing going on. There was also residue of filament inside the hot end before I ran anything through there. So anyway, yeah, let me know. And what we're going to do is I'm going to either put my money where my mouth is or put my foot where my mouth is, and I'm very good at both of those things. And we're going to see if we can't address some of these issues, how difficult it would be. The plan is, and it might be a little bit of a longer video, we shall see, but we'll start off with like the free and easy stuff, such as just adjusting some settings, some of the defaults on the card, some slicer things that may or may not have issues. We'll have to see. And we'll do that first. Then we'll do simple things like, hey, 3D print this or that or the other thing. It'll improve your life. Put some cheap fans on there. That time, the fans have to go. The fans have to go. And then get into more advanced things, replacing hardware, yada, yada, yada. So what are my expectations for this? Well, I think we can get some pretty decent prints off of this. I think it could probably be a pretty decent hobbyist machine. The fact that it uses stamped metal parts instead of VE extrusions like the Ender, that means that it's not quite as mod friendly as far as the kinematics are concerned. So I don't think we're going to get I actually thought about this line ahead of time when the time came, because I wanted to give somebody a shout out for awesome looking prints. I don't think we're going to be able to get Brendan Builds quality prints. Yeah, that dude's posted some gorgeous stuff, and I don't think he knows me from Adam, so I'm just imagining him watching this video one day and be like, what, me? But, you know, considering our starting point was this and this, well, you know, there's nowhere to go but up from here, right? So, sneak peek into next time, we're going to try some budget cooling solutions, see how that works out. We're going to try replacing the hot end with literally the cheapest unit I could find on the market. We're going to try a new extruder. We're going to 3D print parts. We'll laugh, we'll cry, we'll mod.